So last section we're going to look at is 2.4 part 3. And that's on period changes, which is horizontally stretching or compressing the graph. Now, every graph that we've looked at this week so far has had the same period. The period is the amount of distance you have to travel for the graph to basically do its thing and then start over and do its thing again. How long do you have to travel from here to here for the graph to go through one complete cycle, whether it's sine or cosine? 2 pi. Yep. So every graph we've done so far this week has had a period of pi or 2 pi. What we're going to look now is, we're going to look at is changing the period, either compressing it or stretching it. All right. When you stretch or compress a graph, what operation is it? Is it the multiplying or add subtract? Yes, it's always multiplying when you do some kind of stretch. And if it's going to be horizontal, is that inside the parentheses or outside?
Inside.
Yep, it's going to be inside. Bless you. Bless you. So what we're going to have here is something like that. Sine or cosine. And there'll be a number times x. Okay, I use the letter b to represent that number. Because if we were doing multiple transformations in the same problem, this is the second one we do. Okay, so here's a couple examples. Sine 4x, cosine 2x, sine 1/2 x. These are all what we call period changes. Now, when you put a big number, like 4 is a bigger number, in front of x, what do you think that's going to cause the graph to do?
Shrink.
Right. It's going to shrink it. So if I graph sine x and sine 4x, sine 4x is going to be compressed 4 times as much. Okay, I know it's kind of, it's not the biggest. I didn't zoom in much, so it's hard to see. I'll put it on a separate page. Look at that graph. The red graph is going to cycle 4 times for every time the blue one cycles once. Okay, so if you look at the red one, you get 1 cycle, 2 cycles, 3 cycles, 4 cycles, and that's the end of the blue cycle. So you get 4 cycles for every one. The bigger you make this number, where the 4 is, the more and more compressed it gets. If you put in a small number, like less than 1, what's going to happen when you put in a number less than 1?
Stretch it.
That's going to stretch it. Okay, I'm going to zoom in so it's easier to see this now. Okay, that's the original. And now you're going to look at one that's stretched. Okay, so what we say about that graph when you're talking about it as a wave, it has a longer wavelength. Okay, so the blue one is a shorter wavelength, and the red one is a longer wavelength. Anybody have a guess what that does to the sound? Yeah?
Changes pitch.
That changes the pitch. Okay, that means how high or low of a sound you hear. Yep. So I'll do some examples of that. All right, so period change is going to stretch and compress the graph horizontally, or you could say along the x-axis. So if the b value, remember this is the b value, if that is bigger than 1, greater than 1, the graph is going to compress. The bigger the number, the more it compresses. If b is between 0 and 1, it's going to stretch it. The closer you go to 0, the more stretch you get. Point 1 is going to stretch the graph out a lot. Point 9 would stretch it a little bit. Now, we did look at when we did stretching yesterday. We looked at what happens when you have a negative. Okay, and what does a negative usually do? Or what does a negative always do to the graph? Yep.
It reflects it.
It reflects it. Today, we're not going to be looking at ones that have negatives for b. B will only go between 0 and 1. It will not go negative. Does everybody have those two things? So what happens if we want to figure out what the new period is? Okay. It used to be 2 pi. It's going to change. So there's a formula to figure out what the period is going to change to. You don't need to do a graph to figure it out. Okay, there are going to be some graphs later. But to use this formula, you don't need a graph. To find the period of a new graph, you take the original period, which is 2 pi, and you divide by b. And remember what b is? B is whatever is right in front of the x. Right, so you're going to have, I think it's 4 questions on the test where you don't have to do any graph. I'm just going to give you an equation, and I'm going to ask you to find the period. You'll have 2 where I say find the period, and you're going to have 2 where I say find the amplitude. Okay, we did amplitude yesterday. That's the absolute value of the number in front. Okay, let's see if we can find the period of this one. First of all, when you put a 2, does that stretch the graph, or does it compress it? Yeah, it compresses it. So when we find the period of this graph, it should be smaller. It should be compressed, shrink. It should be smaller than 2 pi. All right. So let's find the period. When you're finding the period, what always goes in the top of the formula? Yeah, you always put a 2 pi. Now, what you put in the bottom is different. You have to put b. What's b in this case? 2. I want everyone to understand the period is not 2. Okay, the period is not the b. B is part of the formula to find the period. Okay. So now, when you do 2 pi divided by 2, what do you get?
Pi.
Pi. So that means instead of having to go all the way to 2 pi for this graph to do a full cycle, it's going to do a full cycle by the time you get to 1 pi. Because you compressed it. All right, let's try that one. Let's find the period of cosine 5x. Okay, what's going to be my formula or my fraction to find the period? Yep.
2 pi over 5.
Yeah. And this time, you can't really reduce the 2 and the 5. If it was like 2 pi over 6, then I would reduce it. Okay. But nothing reduces. That's your final answer. Yes?
Hager.
Yep, same. Okay. And this one. Sine of 1/4 pi. Okay, what should happen here?
The graph should stretch.
It should stretch. Okay, the period should get bigger. It's going to stretch out. So you're going to have to travel a lot further to get one full cycle. Okay. What's going to be my formula to find the period? What are we going to have in the top and what in the bottom? Yep.
2 pi over 1/4.
So it's 2 pi over 1/4. Okay, how do you divide by a fraction? Yeah.
Just multiply.
Okay, did you change it to multiply? What are you going to multiply?
2 pi times 4.
Yep.
And then multiply the 1/4 by 4, by 4 over 1.
So we're going to have 2 pi, yeah, and then times what?
By the denominator, so 4.
Yeah, by the reciprocal of the denominator. So you keep the top the same, and you flip the bottom and multiply. And once you simplify that, that's your answer. So 8 pi. Is that a bigger period than the original?
Oh, yeah.
Yeah, it's 4 times as big because the graph stretched out 4 times as much. Okay. So any questions if I give you something like that on the test? Okay, now what if I did this? What would be the period now?
It's going to be 8 pi.
It would still be what?
8 pi.
8 pi.
Because it's still inside the parentheses.
Right. I didn't change anything inside. This number on the outside doesn't affect the period at all. What does that number do?
Stretch it.
Yeah, that's a vertical stretch. So if you do a vertical stretch, that's going to make it 3 times as tall. But that doesn't affect the period. Okay. 3 times as tall would look like this. Those two graphs have exactly the same period in terms of how quickly they cycle. So what if I did this? What if I put a +2 on the end? What would that do to the period?
Same.
Still stay the same. What does the +2 do?
Pushes it up 2.
Yeah, it just pushes it up 2. So if that's your original graph, and you just take it and push it up 2, you haven't changed anything about how quickly it cycles. Yep. So you have to know what number to focus on when you're trying to find the period. Any questions on that? All right, so we are stretching and compressing along the x-axis. So when you have your coordinate, what part of the coordinate is going to change? Yeah. Yes, the x. So that means what part of the coordinate is going to stay the same?
Y.
The y. Since the y's stay the same, we can copy those down from the original table. So the original table, I kind of have a little bit off to the side here. If you forget what they are. But we did those in the notes on Monday. Alright, so unfortunately, because the y's stay the same, that means we have to work with the x's. The x's are the numbers that have pi's in them. We don't like to work with the pi fractions, but this time we don't really have any choice. We have to. Alright, so how do we figure out our new values? What I'm going to do, I'm just going to reword this a little bit. To find new x values, you're going to divide the old x values by b. To find the new x values, divide the old ones by b, which is the number in front of x. That's pretty much the shortest way to say it. Now, if you have to divide by b, okay, and b was a fraction. So let's say that you had a fraction in front of it, like this one. B is a fraction. Dividing by a fraction is the same as what?
multiplying it by reciprocal.
Exactly. So instead of dividing by b, sometimes, depending on the problem, I might multiply by its reciprocal. Depends on the problem. But dividing by b is the same as multiplying by the reciprocal. All right. Any question on that? All right. And by writing it that way, I think I was able to eliminate some other things I was going to write. So that's it. All right. So let's try some examples. Okay, so sine 2x. Now we know all the transformations, and on the test they're all going to be mixed up. Okay, it could be in any order. What tells you that this problem is a period change or a horizontal stretch or compression? You have to tell me two things. Yep.
Multiplication.
It's multiplication.
Yeah, it's inside the parentheses.
And it would be inside the argument. Okay, they don't have parentheses. You don't need the parentheses. But it is multiplication, and it's inside. If it was multiplication outside, that'd be different. But it's inside. Okay. So we know that it's going to be a period change. Which values stay the same?
What?
Yep, we're not doing anything up and down today. It's all left and right. So then what are my y values?
0, 1, 0, -1, 0.
Yep. And as I've already said several times, you're going to get 1 point for each x value you get right, 1 point for each y value. So the table is 10 points on the test. All right, now the x's. Okay, I'm going to put the original x's off to the side. And it says, take the old x's and divide by b. So we can think about it two different ways. What are we going to divide all the old x values by?
2.
Yeah, we're going to divide them all by 2. Or, that's the same as multiplying them by what?
1/2.
Yeah, 1/2. So basically just take half of all of these. Okay. Half of 0?
0.
0. What's half of pi over 2? Pi over 4. And then what's half of pi?
Pi over 2.
Pi over 2. Oops. I was thinking ahead a little bit. What's half of 3 pi over 2?
3 pi over 4.
Yeah, just imagine just putting times a half right there. Multiplying them all by a half. So 3 pi over 4. And what's half of 2 pi?
Pi.
Pi. And that is where your new points are. Now, the original values were all equally spaced. We just took half of each one of them. Are these still equally spaced?
Yes.
Yeah. This is, if you did it in degrees, I think you'd see it easier. 0, 45, 90, 135, 180. They're all 45 apart. They normally would have been 90 apart, but we divided that distance by 2. We compressed it. Okay. All right. Any question on the table? All right. Let's make our sketch. So we've got 1 and -1. You're not going to have to change that for the y's. All the problems we do today. So 0. Pi over 4. Pi over 2. 3 pi over 4. And pi. Now, some people look at those and they say, well, they don't look equally spaced because it doesn't look like there's a pattern. It doesn't look like there's a pattern because they all don't have the same denominator. But if they did have the same denominator, this would be 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So there is a pattern. All right, now just graph your points. So we got 0, 0, pi over 4, 1, 0, -1, back to 0. And that's your graph. Now, it doesn't look any different than the graphs I did all week. How come that graph doesn't look squished, even though it is?
Because of just how the table is set up, or the actual number line is set up.
Right, because of how I set up my number lines, how I scaled it. Okay, if you change your scale, it's always going to look the same. And that's what we do. We change our scale. That way, if we really stretch it, we don't need a huge piece of graph paper. Any question on that? All right, let's try this one. Cosine 1/4 x. Okay, what are the two things that tell me this is a period change?
Inside parentheses,
Inside.
multiplied by a 4.
Yep, something's happening inside, that means horizontal. It's multiplying, that means it's a stretch or compression. Okay, so which column is going to stay the same? Y stay the same. What are my y's? But just be careful, you got to give them to me for cosine.
1, 0, -1, 0, 1.
0, 1. Okay, what are my original x's?
0, pi over 2, pi, 3 pi over 2, 2 pi.
2 pi. And now we have to divide all the original x's by b. So what am I going to divide all of these by? We're going to divide them all by 1/4, that's kind of confusing.
You can just multiply it by 4.
Right, we're just going to think of it as times them all by 4. Okay, what's 0 times 4? That's 0. Now pi over 2 times 4, you just multiply straight across. Think of it as 4 over 1. It's 4 pi over 2 times 1.
Which would be 2 pi, right?
Okay, that would be 2 pi. What's pi times 4? 4 pi. Now, if you look at the pattern you have for the first 3, it's got to continue the same pattern. So what do you think the next one would be?
6 pi.
6 pi. And the last one?
8 pi.
8 pi. So it's going up by 2 pi each time. That's a very big stretch. Okay. Remember, you only had to go to 2 pi, and you could see a full cycle. Now you need to go 4 times as far, because you stretched it 4 times as much. That's what a 1/4 does, stretches. All right, now, are these x values all equally spaced?
Yeah.
Yeah, and I think it's easy to see because you can just look 0, 2, 4, 6, 8. That's easy to see the pattern. Okay, so use those labels. So 0, 2 pi, 4 pi, 6 pi, 8 pi. And we have to graph 1, 0, -1, 0, 1. Okay, so 1, 0, -1, 0, and 1. And that's your sketch. Okay, it doesn't look any different, but look at the axis. That's been scaled to be a lot bigger numbers. Okay, any question on that one? All right, so let's try this one. Sine of pi over 2x. Okay, this time it's the same transformation. Multiplying and it's inside. So we already know the y's stay the same. Okay, x's. Okay, once you figure out the first couple, you'll be able to write them all down because they have to follow exactly the same path. Okay, so we have to divide all of these by 1. Divide them by pi over 2, or multiply them by what?
2 over pi.
2 over pi. So let's think of it that way. Okay. What's 0 times 2 over pi?
0.
So that's 0. And then pi over 2 times 2 over pi.
1.
Yeah, 2's cancel, and the pi's cancel, and you get 1. When you multiply here, what cancels?
Pi's.
Just the pi's. And what are you left with?
2.
2. So what do you think the next one is?
3.
3.
4.
And pi's cancel. You get 1. So this is the only problem we've graphed so far this week, where all the x's are nice numbers. And all the x's are nice numbers because of this. That canceled all the pi's. So on your graph this time, you really don't need to label anything. Because if you don't put any labels, you always assume each tick mark is 1. And this time, it is. Okay. 0, 0. 1, 1. 2, 0. 3, negative 1. 4, 0. And then make your sketch. So let's figure out if that's stretched or compressed. What do you normally have to go to get to a full cycle in a normal graph that's not stretched?
2 pi.
You have to go to 2 pi. What's 2 times pi roughly?
4. No, 6.
Like 2 times 3.14.
6.14.
6 point... 6.28. So normally you have to go about 6.28 units to get a full cycle in. How many units did we have to go?
4.
We had to go 4 units. So did this stretch or compress?
Compressed.
Yeah, it compressed a little bit. It didn't compress a lot. But you only have to go to 4 units now, where you used to have to go to about 6.3 units. Yeah, so that compressed. Any question on that? All right, so there's a couple things that have to do with sound, different frequencies. But first, let me just put up a list of all the test topics because we don't have a video tomorrow. So I'm going to put the list in today's video.
Oh, that's it.
Yeah. All right. So for the test topics, you don't have to know how to graph sine and cosine, and you have to know how to do all 4 transformations. So phase shift, vertical shift, what else? Amplitude change.
Should I get back on my water bottle?
Yeah. And period change, the one we did today. So all the shifts, all the stretches. If you want me to write them like in their normal, this is a horizontal shift. There really is no other name for that one. They just use vertical shift. That's a vertical stretch. And period change is a horizontal stretch. Okay, if you're not sure what one is what, we can make a chart for that. So C sine bx plus A plus D. Okay, let's start with A. Which transformation here is A? Yeah, which one? That's a phase shift. Yep. Okay, so that one's A. All right. How about the vertical shift? Which one is that? That's D. All right. How about the amplitude change? Which one is that?
C.
That's C. And what about the period change?
B.
B. So there's a diagram that shows you what each letter does in the equation. And it doesn't matter if it was sine or cosine. So on the test, you'll have, I think it's 6 of these kinds of questions. Okay, doing the graph. And then the other thing is finding amplitude and period. So if I gave you something like 3 sine 2x plus 4. Now, we didn't talk about how to graph something that complicated because it's got multiple transformations. I'm just going to ask you what the amplitude and period are. What's the amplitude of that? 3. It's the absolute value of the number that's in front. And what about the period?
Pi.
Yep, it would be 2 pi divided by the number in front of x, which is pi. So there'll be 4 questions like this. You have to find amplitude and period. So any questions on test topics? Okay, so the homework will be a worksheet. It's the 2.4 part 3 worksheet that says period change. And reminder, tomorrow that'll be a review day.